All right, hi there. This is video number 25. It is chapter 5, section 4, and this begins a large section that is called factoring. Basically, we're undistributing, unfoiling, we're pulling problems apart so that this is used to solve for x by pulling it apart and turning an addition and subtraction problem into a multiplication problem. So we're going to utilize a number of different types of factoring. I think 6. We're going to have 6 types of factoring altogether. And this one is the first one, and it is the most common one, and it's called factoring out a GCF, which stands for greatest common factor. And the definition of a greatest common factor is it is the GCF is the largest monomial that will divide evenly into every term of a polynomial. And it's your job to figure out what that GCF is. Okay, I'm going to show you a method that will work every single time, but it is cumbersome and frankly, it's annoying. The better your multiplication skills are and the better you understand variables and dividing them, the easier this will be, and you can avoid that cumbersome step every single time. All right, so I'm going to go through one of these first. So we are going to factor 12a squared b minus 15ab squared. Okay, so your goal is to first find the GCF, then factor it out. Essentially what we're doing here is undistributing. If there's 2 terms or 3 terms, undistrib. Okay, so if you can see a common factor, now I can see that there is a 3ab that's going to come out of these. Okay, that's going to be my GCF. It's a common factor that will divide evenly out of 12 and out of 15, out of an a squared and out of an a, out of a b and out of a b squared is a 3ab. But let me show you this cumbersome method of getting those if you can't see these right off the bat. So what you're going to do is literally use a factor tree. So you're going to factor. 12 is 4 times 3. 4 is 2 times 2. So the 4 is gone, right? Because this is 2 times 2 times 3 is 12. A squared is a times a, and b is just a b. So I'm breaking these down into their simplest pieces that you possibly could. 15, I'm going to just get a different color so I don't have too much of the same color, is 5 times 3. Those are both primes, so we don't have to go any further with that. A, and b squared is b times b. Now what you want to do is identify things that are exactly the same in both terms. Well, I'll use a highlighter here to identify those. So I have some 2's in the 12, the first term. I don't have any 2's in the second term, so I can't use that. But I do have a 3 in each term. And I have an a common to each term. There's an a here and an a here. And then one red b and one kind of orange b. And so they have those in common. So if you can highlight those kinds of things, then you use only one of them. the 3AB is common to both. So this 3AB, 3AB, 3AB is my GCF. Okay. And then essentially what you're doing is you're taking anything that's left over and not highlighted, or dividing, whichever way you want to look at it. What do I have left over on the left-hand side that's not highlighted? I have 2 times 2 is 4 and an A. So this is going to be a 4A is left over. And if I were to remultiply the term out here times the term in here, I'm going to get a 12a squared b, which is what I started with up here, 12a squared b. Okay, I have nothing left on the left-hand side, so I'm done. I'll utilize my sign here. And then what's left that I didn't highlight over here, well, that's a 5 and a b. And again, if you multiply 3ab times negative 5ab times 5b, you get 15ab squared. And that's exactly what you get here. So you're done. This is the finished product. Okay. And you can always check these by multiplication. You should get exactly what you started with. So what you're doing is you're finding your GCF. You're putting a parenthesis after your GCF and then putting what's left over. Now, let me show you same problem. 12a squared b minus 15ab squared. I mentioned at the beginning that I could tell that this 3ab was my GCF. Well, how? I know that a 3 is the only thing that's going to divide evenly into 12 and 15. And then you take the smallest variable terms out. So I know a 3 is going to come out. Here I have an a squared and an a. Well, the smallest one's an a. They have a's in common. And here we have a b here and a b squared. So a b is going to come out. That's your GCF, put parentheses, and then essentially you're dividing 12a squared b divided by 3ab. And you get 12 divided by 3 is 4. This would leave you an a, and the b's are going to go away. I'm dividing 15ab squared by 3ab. And I get a minus 5. The a's are going to cancel out and leave me a b. And so both of these are the identical things, right? Right here and right here. One you got by factoring. This one's by factor trees. This one is just by visual knowledge of multiplication and division. And you can do that either way. I don't need to see all of these steps up here, but some of you will need to show them. And if you need me to work through a couple with you, let's do that. But I'm going to continue to do mine this way down here visually because it's not quite as cumbersome. Okay? Unless we don't really know what one is, as in the next example. So this one is 48 x squared y plus 96 xy minus 108 xy squared. All right, well, I don't know what the common factor is to 48, 96, and 108. So let's actually walk through this way. I'm going to factor the 48, and that is 6 times 8. 6 is 3 and 2. 8 is 4 and 2. And the 4 becomes another 2 and 2. So anything that's not prime essentially goes away, right? And then I have an x, and a y. I'll do these all in different colors. 96 is 3 times 32. Well, 32 is 8 times 4. 8 is 4 times 2. The 4 is 2 times 2. And this 4 is 2 times 2. So that 4 is gone, the 8 is gone, the 4 is gone, the 32 is gone, leaving you 1, 2, 3, 4, 5 2s and a 3. And then you have xy. And we'll do the 108 in green. This is 3 times 36. Well, 36 is 6 times 6. 6 times 6 is 3 times 2 and 3 times 2. So the 6's are gone, and then I have x, y, y. All right, well, now we want something common to every single term. So if I look at these, let's start with the variables. I have ay, and a y. I also have an x in every term, an x, and an x. And remember, it has to be in every term in order to move forward. Looking through here, I have a 3 in every term, a 3, a 3, and a 3. And I have at least two 2s, right? So I have 2 2s here in the green term. I have 2 2s in the blue term and 2 2s in the red term. So I take and I multiply, and no other, right? There's another 3 left over here in the green term. There's a 3 left over, and that's the only thing. Oh, there's 2 3s left over, but there's no 3s in any other term. There's 2s in the left and the red and the blue term, but there's no more 2s in the green term. So we are where we are. So you take one of those highlighted sets of information. So I have what's highlighted, 3 times 2 times 2, 3 times 2 times 2, an x and a y. And so we multiply all those together. So 6 12, so this is 12xy. And then you can either divide each of the original terms by 12xy, or in this case, since you laid them all out, you could just take what's all left over. So for example, in the red term, the 48xy, I have a 2, and you multiply anything left over. So 2 times 2 is 4, and I have an x left over. So that's 4x. And then in the blue term, I have a 2 times a 2 times a 2. Well, that's 8. And no variables because I used them both. So I have plus an 8. And then in my 108, I have the 3 and the 3, which is 9. And remember, there was a negative sign up there. So minus 9. And I have a y left over. Okay? And this would be the answer to that. So remember, you're factoring out the GCF. Let's do 2 more quick examples. And this one looks like 9x cubed y squared z plus 9x squared y squared z squared minus 12xy squared z cubed. All right, so I'm going to do this just visually. I know a 3 goes into 9 and 12, and that's it. So I have a 3. I'm going to look at my x terms. I have an x cubed, an x squared, and an x. So I'm going to take the smallest one, which is just the x. That's from the 12xy squared z cubed. Then I'm going to look at my y's, and the first term's y squared, second term's y squared, third term's y squared. So I'm going to take a y squared out. And then my z's, in the first term I have a z, then a z squared, then a z cubed. So z is my smallest one. And now essentially what's happening is I'm dividing all of these by the GCF. Okay, and so this is going to leave me with a 3 for the first term, right? 9 divided by 3, this is a 3. I'm going to have an x squared. The y squareds are going to cancel each other out, and the z's are going to cancel each other out. All right, move on to the next term. 9 divided by 3 is 3. X squared divided by x is just x. The y squareds cancel out. Z squared divided by z is just z. So I have a 3xz. And then I have negative 12 divided by 3, which is a negative 4. The x's cancel because there's an x on top, x on the bottom. Y squared and y squared, so those will cancel. And z cubed over z will leave me a z squared. So I have minus 4z squared. All right, so that's the way to do that without using all that breakdown method. And again, if you wanted to check, you could, so to check, you could redistribute all of these, and this would give me 9x to the third y squared z plus 9x squared y squared z squared minus 12x y squared z cubed. And this should be the same as what you started with if it works and you're correct. And also, you should have no GCF left in here. All right, so that's kind of a like if you had a 6, and an 8, you could still take another 2 out, right? So you need to make sure that you're taking out the largest thing and that you have no GCF left over in here. So in the first term, looking at variables, you have an x squared, an x, and no x. So that's great. There's no y squareds anywhere. And you have no z, a z, and a z squared. So they don't have any GCF common. All right, last problem is just so you know how to handle it in varsity. It's going to look like this: 15a squared times a plus b squared plus 6b squared times a plus b squared. My first question is, how many terms are there? Well, remember that terms are separated by plus and minus signs. So this is a term, and this is a term. And so there's only two terms in this problem. Now your question is, what's common to both? And what might stand out to you is that this parenthesis, a plus b quantity squared, is in both of them. And so that, it's a weird looking GCF, but it is actually the GCF. So you can take this guy out with the 2 attached to it, the squared. And so remember, your GCF always goes out front. So a plus b quantity squared. Make sure it looks just like it does in the problem. Don't leave the parentheses off. And then what's left over would go into your next set of parentheses. So I would have parens 15a squared plus 6b squared. And varsity will take this as an answer. Technically, I would ask you to actually factor this a little bit further, because I mentioned before you should have no GCF in this quantity, and you do. What can come out of both a 15 and a 6, right? That's a 3. So I'm going to actually pull that 3 out. It would go out in front of the entire problem. And then if you take a 3 out of 15, you get a 5a squared, plus take a 3 out of a 6, you get a 2b squared. And now this is as factored as possible. So this is going to be okay in varsity. So it's really as far as you need to go. However, if you were doing these for me on paper, I would expect that you would factor another GCF out of that, even though it's left over. Okay? All right. Well, that wraps up this one. 17 and 18 are a little bit strange. They're very, very simple, but there's a lot of words and not a lot of math. Actually, nothing for you to do. So I'm going to let you just figure those out. And if you can't, just come ask me about them. Okay? All right. So this is, what was this? Chapter 5, Section 4. All right. Toodaloo.